Hello, nice to meet you all. What I want to talk about today is actually Tezos on AWS. As you probably know, we at AWS have all kinds of infrastructure available for builders to use. And one thing that we worked together with Chris Pinnock from the Tezos Foundation on for the last couple of weeks or so is actually how you could run a Tezos node on AWS if you ever wanted to. And that's really what I want to talk about, and then really enlarge the landscape, if you will, and talk a bit about what other AWS services you could possibly use for Tezos environments. As you know, at AWS we have a couple of, well, probably 250 or so different services for all kinds of purposes. And in particular, anything related to key management is, of course, a general purpose service, but it can be used in a very useful way for anything Web3 related and for Tezos specifically. So for this presentation, I will start with a general overview on what's possible on AWS for Web3, what you can do with the existing services and which ones are specifically aimed for Web3. Then I'm going to focus on the specific launch of Tezos Node runners, which is today, really. I'm proud to launch that script finally to the general public, which is basically running a Tezos node on AWS in your own account. And then, as I said, talking about some other services, specifically signing and key management and what you can do with that. Now, Web3 on AWS. I'm going to click through that quickly. We have really three different tiers of things that you can do on for Web3 on AWS. At the very bottom layer, of course, our core building blocks, compute and storage and anything related to that, databases, observability, containers, IoT, anything like that. So, of course, you can always go about, just spin up your own EC2 instance and do whatever you want on that instance. Use some storage, S3 or elastic block storage if you need block storage. Store your data on there. And that's pretty much how you'd run a node normally on AWS. You'd spin up an EC2 instance, install the node, configure it, configure the storage options, and then start it up. And that's what's always available for anything really. There are some more specific Web3 services. On the very top, or so-called managed services, AMB Access and AMB Query, those are either node provisioning, so if you need a blockchain node or if you need some data from blockchain. Both are not Tezos specific. For now, AMB Access and AMB Query support mostly, or support Ethereum, Bitcoin, and Polygon, but not Tezos yet. However, there is this layer in between, which we call blueprints. And that's our expansion layer, if you will. With blueprints, what we are offering is so-called CDK scripts, Cloud Development Kit, that allow you to pull in different services and really have building blocks for Web3 related things. One of the larger blueprints is the so-called node runners, which we see on the very right there under nodes. Node runners is our initiative to add more blockchains very quickly to AWS. With the node runner scripts, you're able to go to GitHub, download the script, run it in your own account, and it will spin up the relevant AWS infrastructure for you to run a node for various blockchain and for Tezos nowadays. We have some other services as blueprints. On the analytics side, we have a self-hosted graph node and the open data set, which is currently Ethereum and Bitcoin. And then on the key management side, we have pretty much all kinds of services related to storing a private key securely and making sure that that private key never gets exposed in plain text to some malicious actor. And that can include actually the root user on an EC2 instance. You actually don't want the root user of an EC2 instance to be able to have visibility into a private key, and with various services that we have, particularly Nitro enclaves, we can ensure that it never gets exposed to that. So that is something I'll be talking about later. And the node runners is something that I want to talk about now. So Tezos Node runners. We have this repository on GitHub, which is our node runners initiative. With that, we want to support as many blockchains as possible for people to run their nodes on AWS. The reason for running a node on AWS or running your self-hosted node can be plenty. Most of them is if you really have many queries to your node, it's normally more cost-effective to run your own node than rely on some third-party service that charges you by request. So with the node runners, we allow you to do that, and by building that, we of course incorporate all these best practices on AWS, so we take away the guesswork of it. At AWS, we have over 650 instance types, so it's fairly hard to get the right one for your node. And with the node runners, of course, that's pre-configured, so you already know that's a good instance type to use for this particular node. Same with storage. EBS storage or block storage has different configurations, and we choose the one, GP3 in this instance, that's most suitable for that. Node runners supports a handful of blockchains, something like 10 or so. And after we've worked on it for a couple of weeks, we're now launching Tezos for it. So I'm really proud to present that. That's a link. If you search for AWS node runners on the internet, you'll end up there, and you can easily go to the Tezos node. On the right-hand side, you can see what the website looks like, and also the architectures that we spin up. I'll go into that in a bit more detail. Just on the left-hand side where it says blueprints, you see how many blockchains we're supporting. For now, we are adding more and more, and we're open to contributions, not only for blockchain nodes, but also for other things like, say, a Farcaster node or a Graph node or anything like that. So. But the main important thing, of course, for today, we are supporting Tezos. Yep. Now, if you go to that website and decide to run your own node on AWS, you'll end up with a choice of 3 different node types. These ones, a single node, which is basically exactly what you expect, one node that's running for you, indexing the blockchain, and you can then send your RPC calls to it. That's really good for development purposes, obviously. You have your node, it's up and running, but you don't really care for high availability yet. In any kind of production environment, that might not be enough. You might rather want to have a highly available node setup, and that's where the HA nodes, high availability nodes, come in. The main idea with that flavor of our node runners is that we're not only spinning up one node, but several, 2 in its default configuration, and put them behind a load balancer. So if one of these nodes goes down or is overloaded, the load balancer will then route the request just to the other node to respond to them. Also, they are in a so-called auto-scaling group, so if there's a huge demand on them, we can spin up even more nodes behind the load balancer so that the load balancer scales with your needs. For the HA nodes, we have this so-called snapshot node in between. I'll go into more detail for that in a bit. That is really something that we need to run the HA nodes. So the choice, if you use the node runner script, is normally between the single node and the HA nodes. I'll go into them in more detail. A single node is exactly what you'd expect. We have an EC2 instance at the very middle. It's an RPC node running on it, and it has a security group around it that basically says RPC calls are allowed only from within the VPC. So other EC2 instances in the same VPC can call the node, but no one from the outside. However, of course, it does communicate to the outside internet, to other Tezos nodes for syncing the blockchain itself. So there's really not much to it. if you look at the HA nodes, of course, the architecture becomes a bit more complicated. And this is what it looks like initially. We have a sync node that is just like the single node, connects to the Tezos network, sits in a public subnet in a VPC, but periodically we use that sync node, stop it, and send all its data, store it on S3 in our storage, block storage, object storage solution. So basically once a day, we'll turn down the node, send all its storage to S3, and then we spin it up again to keep track of the blockchain. Now, why do we do all that? Because now we are having the actual HA nodes, 2 instances in this type, in this case. Both are sitting in different public subnets and in different availability zones also. So if one goes down, it normally doesn't affect the other. And these type of nodes, we want to spin up very, very quickly. Because, of course, we want to potentially scale horizontally. So if we do have many, many more requests and a peak in requests for some reason, we want to be able to spin up these nodes very quickly. Now, if you start up a node, it normally would import the initial snapshot from a public source, and that takes about 45 minutes or so, 30 to 45 minutes probably. And that's what the single node does. That's also what the sync node does. But that's a bit too long for the HA nodes. So for the HA nodes, we want to be able to spin them up much quicker than that. So instead of downloading the data initially from the snapshot, what they do is they take the initial data, import it from S3. And that's, of course, just a copying over within the AWS network, so it's fairly quick. And because the data that sits in S3 is from a trusted source, because we put it there in the first place, we can just import it as is. So that makes the initial startup of an HA node in probably something like 5 minutes or so, instead of 45, because we do not rely on importing everything from a public snapshot. And that's what the sync node is for, basically providing the data source for our HA node and having that as a trusted data source because, well, we created it in the first place. And then, of course, if we have some other applications accessing these nodes, they go via load balancer, and the requests will be routed among the RPC nodes. We'll never access the sync node directly from other apps because its only purpose really is to make sure that we always have these the data for initial import available. Now we talked about the architecture, what it looks like. What does it mean to spin that up? We've provided the cloud development kit script for it to spin up these nodes, which is basically something like AWS Terraform, if you will. Infrastructure is code that you can run in your own account, and that spins up the infrastructure for you. So there's really only 2 things to it. Initially, you have to set some config options. And the important ones are, of course, the AWS account ID and the region that you want to use for your nodes. And then the network history mode, where you want to download the snapshot from, these type of things. The other things can normally just be left as is, but of course they're there for your configuration if you want to change them. So once you've set up the configuration, it really boils down to running the CDK deploy command, in this case for the single node, or if you want the HA node for the HA nodes. And then, of course, it takes a while and it spins up your node. For the single node, what the CDK script does, then it creates all the resources, starts the blockchain client, the Tezos Node, and then it starts syncing from the public snapshot. The CDK script finishes before that, so it takes something like a couple of minutes probably to run, and then the node will keep syncing after that. So it takes then again 30 to 45 minutes or so until the node is actually ready for a PC request, but the script itself will make sure that it's up, that it's up and running. The script itself is written in Typescript. If you're using it, basically what you're doing is cloning the GitHub repository, so you have really the full control over what's being run, and you can change everything that's in there. It's just sort of our condensed idea on how to spin these things up quickly. Now that is for node runners. That's of course the base core service. Once we have a node up and running, then the interesting thing starts. So what if we want to start a baker, actually baking for us? We need a node for that, but we need some more things to it. So that's what I want to go into now. And these things are more on the conceptual side of things. I want to explain some concepts that we have and some services that can be used on AWS to do that. But we don't have CDK scripts for them yet. The CDK script that we're launching today is just for the node runners, the thing that I explained before. Now, if you want to do a baker node, then of course you need a remote signer, and I did mention that before. You want to make sure that the key, the private key that you're using to sign off on that is never available to any external entity. So the service to use for the easiest service to use for that is AWS KMS. That's our key management service that is able to store private keys for you and even sign a payload with these private keys for you. The KMS service holds the keys, and it is connected to the remote signer who wants to actually sign off on transactions via the private internet connection in the AWS network. So communication between KMS and the remote signer never travels via the public internet. It always stays within the AWS network. The good thing about the KMS is this is a slide I wanted to get to. Sorry for that. The good thing about KMS is that it's completely IAM-based access. So whoever has access to these keys can be configured via AWS IAM access rights. That's of course fairly easy because it is within the AWS framework. Just whatever you're using to set up roles and users and the like can be used to configure KMS. KMS is FIPS 140-2 level 3 compliant. I'm only mentioning that because that has changed somewhat recently, last year. Before we were only level 2 compliant, but now we've received the level 3 compliant certification even for KMS. So that's really good. There's one disadvantage to KMS, which is it's multi-tenant. So we as AWS manage it, we make sure that it's available, we take care of everything really, but it's a multi-tenant service. So it's not, there's only one KMS service within AWS that everyone is using. Of course, we make sure that everything is isolated from each other. That's why we have IAM access rights. But it's really a multi-tenant service. There are cases where you can't really live with that. For auditability purposes, it might be needed that you actually have a single tenant service that's only there for you. We do have a solution for that, which is our cloud HSM. That's our hardware-based security module that you can also use, which is really there for you only. So really only you have access to it. It doesn't follow the IAM access management, so it's really up to you to decide who can access that and who cannot. And even we, of course, even we can't access it. So it's really, we spin up the hardware just for you. It's only you that's running on top of it. And that's really good for audits. But it comes with a lot more work that you have to do to manage that. For instance, with KMS, we make sure that it's available and that it doesn't go down. With the Cloud HSM, it's really on your plate to make sure that it's highly available. If you spin up just a single Cloud HSM instance, that means exactly that. It's one instance and one availability zone that's there for you. If you want to have it highly available, you can use it in a clustered way, where we sync between these Cloud HSM instances, and then you can, of course, put them in different availability zones, but it's really up to you to manage that. So if you have much more control over Cloud HSM to really configure it the way you want to, but it is much more work. And also it doesn't follow the IAM access policies, so it's really up to you to make sure that you get the access management correct or manage it correctly. It's also FIPS 140-2 level 3 compliant, just as KMS is. And for signing purposes, it also can be integrated with KMS. So you can use the KMS crypto library, basically for signing, decrypting, encrypting, and use Cloud HSM as key store, which is then accessed via KMS. That makes it somewhat easier to use and sort of incorporates the higher security that Cloud HSM has, of course. Excuse me. Thank you for that. That is all I wanted to present today, saying how you can use AWS services for Tezos. And of course, I'm still here for any questions that might arise.